Good evening, ma'am. Shall we wait for 1 or 2 minutes before some participants join?
Sure, sir. Yeah.
Yeah. Okay. Hello.
Hi, sir.
Hello, ma'am. Ma'am, shall we start? I think are we good to go before any? Uh,
Yeah, sure, we
uh,
can start.
yeah, yeah.
Do you want to wait for another 2 minutes for everyone to join, or like I can start otherwise?
I will first start with the this introduction, and then I
Sure,
think yeah, I'll
sure, sir.
make you. Uh, Um, Session in recording has started. Yeah. Okay. Good evening, all the participants, all school, my dear students, and today we are having a session. Okay. So this session is on data engineering in big data and cloud ecosystems. So we have a guest session, uh, guest lecture with us, Ms. Pooja Chopra here. Um, so, ma'am, she is working in Palo Alto Networks as a senior DevOps engineer. Um, she is a dedicated and result oriented engineer for past 10 years, and she has worked in various technologies like cloud and Kubernetes management, infrastructure as code, CI/CD automation, security and compliance, identity and access management, monitoring and optimization, automation and scripting, etc. She has worked as a data analyst earlier, okay, and worked as in many places in cloud as well as in data engineering. I welcome you, ma'am. Now the platform is over to you, and I think uh, and I expect all the students, okay, so to be uh, cooperate with the ma'am, and I hope everyone will enjoy the session. Okay, yeah. Thank you so much for joining, and over to you, ma'am.
Thank you so much, sir. First of all, thank you so much for giving me an opportunity to be a part of this lecture. I just want to give a little bit intro to who I am. So basically, I've been born and brought up here in Bangalore, and then I finished my engineering in computer science from RV College. And then I worked in multiple industries, but starting with like State Street, which is a financial tech organization where I worked both as a machine learning developer and a data analyst. Got an opportunity to work in different kinds of projects doing ML, AI, and data engineering, of course, the analytics part. And then I moved to Palo Alto Networks, the cybersecurity. Got because cybersecurity is another booming industry right now. So worked on different projects, right from like deploying the applications to monitoring the applications on infrastructure end to end, like application side plus the infrastructure development side. So that's about me. And the reason I just wanted to give a quick intro is because when we are talking about big data and all of these technologies, so with my working experience, I just want to ensure that with the delivery that I have, like today, it should be an interactive session where I also give my experiences so far that I've worked in corporate, and you'll be able to relate like whatever you're learning today is going to be a really advantageous thing when you start working. So it's not like it's just going to be like theory that you want to pass the exams for, but it's going to be really helpful in your professional career ahead. And also, please like do stop me where you feel like you need more information. If there are any queries, I'm always available. And after this session as well, I'll share you my details, email and LinkedIn profile. So probably like if you have anything to reach out, please do feel to reach out. I just don't want to this to be like a theory where I'm just passing concepts, but I want you to be like more interactive. And we'll also have a hands-on session, so I did go over the curriculum that you all have. So I'll be more focused on the unit 3, which is big data covering Hadoop and Spark. But for this session, I also wanted to give a little bit of recap in terms of introduction to big data. So let me start sharing my screen. Just let me know when my screen is visible. Just a second. I hope my screen is visible, right?
Yes, ma'am. Yeah.
Thank you, sir. Yeah. So we'll be covering like end to end. So this could be a like a good recap for you, like in terms of like what is big data, some of the things that you've already studied in Unit 1 and Unit 2. So it will be a quick recap or brush up to recall your concepts ahead. And then we'll actually go into the Unit 3, which is like the Apache Spark and Hadoop and things like that. And the relevance will come from definitely the introduction to big data. So let me start by asking, we all know what data is, right? So can anyone just tell me like what is data?
It's a collection of some information.
Yes, right. So data can be anything, like it can be a character, it can be a text. So collection of like characters that we have, that is data. And then when you combine data together, it forms like information. Now, data can be like a physical data, of course, and digital data. So when we talk about digital data, it is something like the binaries, right? The computer language that we all like, zeros and ones. Now, what are the different types of data that we can have? Can anyone tell me? So the different types of data are unstructured data, semi-structured data, and the structured data. So here is an example that I'll provide you in the next slide. But structured by the name, it means that any data that you have, it follows a particular pattern. It follows a particular format. So that is, of course, the structured data. And mostly the structured data, we store it in like databases. Like there are different kinds of databases that we have. And enterprise systems like mostly use a form of structured data. And anything that does not follow a pattern, it is not there in a particular format. So all of that is unstructured data, like any analog data coming, like all your audio and video streams, like it can be in any format, any shape, any pattern. So all of that is like unstructured data. And then we also have semi-structured data, which is basically a combination of structured and unstructured data by the name. So it could be like your email, because whatever you type in like your email in the back end, like it can be stuck like a combination of structured and unstructured, as the name suggests, right? So we have like these three kinds of data, and you can clearly understand by this example that I'm showing here. So unstructured is basically a set of data, what we call as information. So you can see like couple of sentences are written here, like the university has 5,600 students and the ID number is in so and so. But when it comes to semi-structured data, like probably in a metadata format, where it is much more better readable when it is like in the JSON format, as you can see, like the student ID is one and there is a name and things like that. But when it comes to structured data, it is in a table. So it is much more in terms of readability. You can read it better, right? In structured format, because everything is directly written. So if I have to process these three tables, I would definitely process first the structured data, because it's much more convenient in terms of readability, if you have to say so. And then the semi-structured, and then the unstructured data, because it has a series of lines. So I might have to take few more seconds to really process it. And the similar in the backend, also in the computation, the same thing happens. So when it is structured, it is very easy to process the data. But when it's semi-structured, it happens through metadata, so it is much better than the unstructured data, but still takes time. But when it is unstructured data, it takes a little more time, where you have to process the information in a read the information and then process it. So these are the three different kinds of data. Now, what is big data? So we already know like this is the data. Then what is big data? Big data is not just about having like more data, but it's about having like large data, where the data is coming like too fast, it's too complex, and it's not possible for any traditional systems to handle. So that is something called big data. So it is, you can probably say like it's a massive collection of data, and the data set is really huge, that a human definitely cannot process it at once, or a computer system as well. So then we'll also talk about like what is there to process such big data, but I just wanted to introduce that concept of big data. So it's large volume of data. So for example, like let me give you like real world examples. So so we all like search Netflix, right? Like that's the most popular. So Netflix collects about like petabytes of viewing data daily to personalize recommendations, and also all the series and things like that that we ask. And there are like multiple examples like YouTube, all the organizations, anything on social media that you see, like these are like all the real-time live examples of using big data. So that's about it. Now, there are a few characteristics of big data. So as we say, like when you hear the name big data, mostly you would be thinking, okay, it's all like too much data, right? But it's not just too much data, as I've already mentioned, like it is a lot more to it. So there are like four V's that we defined primarily, but I've listed. So whenever you talk about big data, like people would mention, like when you search through different sources, some would mention 4 V's, some would mention 5 V's, some would mention 8 V's. But primarily, the most important ones that I've highlighted here are these 5 V's. The reason I wanted to also say that it is different in different sources is because of the importance given to these characteristics of big data based on the real-time use cases that you use in your enterprises. So for us, like these 5 V's are primarily important because these stands the base. So one is like the volume, velocity, variety, veracity, and variability, as you would see. Now, talking about volume, as we all know, like the data size is too huge that is coming in, so that itself is like big data. Like for example, like Walmart would handle about like 2.5 petabytes of data from customer transactions like every hour. Or if you would also take into considerations like Target, or you can also take like Amazon, Flipkart, and all of those. Now, velocity is like the speed at which the data is coming in. Now, taking the same example, like if you like take about Twitter, so users generate about like 5 lakh tweets per minute. It's not even like per hour, like per minute, like you would have approximately, and this number is just like the minimal number that I've told you. So the velocity at which the data is coming in, it's nothing but the speed. Like, so you're receiving like 5 lakh um, tweets per minute. So that's like huge, right? So that's the velocity. Then variety is basically the data can be in any format. Like as I was mentioning, we have 3 different categories of data, right? Like the types of data. One is structured, one is unstructured, and the semi-structured. So the data that is coming in does not belong to a single format. It can be in multiple formats. So the different formats could be like text, images, videos, or any sensor readings. So that's a different format of data that is coming in. Now, next is veracity, where it's basically like how much do you trust the data that is coming in terms of accuracy. Like, is the data really valid data, or is it like something spam? It is not really considerable. So, do you really like trust that data? Now, for example, a good example could be like AI, like we use Gemini and ChatGPT, right? So, in the background, the model that is training the data, do you really trust that data? Now it's giving answers to you, right? But in the back end, so this characteristic like becomes more important in that scenario, because you're asking a query to ChatGPT and it's giving you the answer, but in the background it has to the data that it's receiving, where it's like huge volume of data that it has been trained on, and it is being trained on based on the prompt engineering that we do. So do we really like can trust that data? Yes, we do, but we also have to provide our intelligence. So that is a different aspect, but veracity plays a very important role here. And then you also have variability, where you're receiving data, you're receiving too much data, but what do you do about the data? Like that data should really add a value to it, right? By value, I mean like a business value. So there should really be a value that why I'm taking so much data, why so much data is coming to me. So these are some of the characteristics of big data, which is like really important. With this, I would like to take a little bit of pause and just get like, are you all following with me? Probably you can like,
Yeah.
okay,
Yes.
great.
Yes, ma'am.
Yes, ma'am.
Yes.
All right, thank you. Okay. Now, as we are talking about big data, the value that I'm again reflecting on the fifth value, right? Like the value part. Now, where is big data even applied? Like all the social media apps that you can think about, it is all applied there. In the background, they all use big data. And all the industries that you're seeing in the right, like be it healthcare, traffic control, telecom, to get the fraud and risk detection, analytics, manufacturing. So the applications of big data is there in every industry possible that you can think. So this is basically to highlight the importance of big data. So that's where I wanted to mention that where big data is even being used. And I have a couple of stats here, and these are like recent 2025 stats, as you can see. Now, the usage per industry, like as I mentioned in the previous slide, like these are all the multiple industries that big data has been applied. But at top, you would have telecommunications with 87%, financial services with 76, and healthcare with 60. And then the market that you would see on the right, like the consumption on all the other industries, so you would see like it is again, like in terms of percentage, like it is just huge. It is huge. And the revenue that is generated from big data, like year on year, you can see like up till 2027 that has been projected. So that's again huge. So it's just like growing. Sorry, I think my screen, just a second. I am sharing back. Just bear with me a minute. I'm like, these controls are just coming in between, so I just want to get rid of them. Yeah. Yeah, so as you can see, the revenue forecast that has been generated from big data year on year, it is just an inclined scope. It is never decreasing, and it will increase. As you can see, it's already projected like till 2027. So year on year, it is really increasing. So these are some of the stats, again, giving you that information that how big data is really important in industries. And second thing is like you have big data, but where it is being applied and how important it is for us to know about big data and leverage big data. Now, when we're talking about importance, right? So now we know that, okay, it's applied in these enterprises, and then these enterprises apply the revenue generated and things like that. But what really is that value that it is applying in the enterprises, right? So when we talk about the value that it has been um, enforcing in the enterprises, it's basically the cost reduction, time reduction, and making decisions. Now, you would tell me that when I'm talking about huge volume of data, then it is increasing cost, right? How it is even reducing cost? And it is also time consuming to process that big data. Then there is a conflict in the statement, right? You would ask me that question, or you would ask yourself that. So then the answer to that is definitely like big data is like huge volume of data. But then when we actually go to each of those industries where big data is applied and look at the real time scenarios, then you would see that big data, having all that data and processing all that data, is in turn giving like lot of other advantages. So we will take a real time example to understand this, but it's actually reducing cost, it's reducing time, and it's helping us because we have all that data pre-populated and processed in our systems. So we are able to make better quality decisions and apply to our products so that the product features are enhanced. So it is really like helping us to find the root cause of the failures issues. And then like there are scenarios where you do a lot of like sales and advertisements, right, where you see the history of the purchases, and then based on like you also say that, okay, this product is being like the most sold, this product is some the least sold, and things like that. So if you don't have that history of data, then you cannot like really get on to the analytics part of it. And then there are many scenarios where you also have to have the data in terms of like security and fault tolerance constraints. So these are like some of the cases, and you'll understand this further when we go over the session much better. But big data is like really important. Now, when we talk about big data and its importance, there are definitely challenges too. So the challenges are basically more data, more storage space, data coming really fast, and then agile business requirements. Business requirements like keep changing. It is not like constant. Like today you'll have like, for example, like I've worked in like many industries, right? So as I was telling, like some people have the features released weekly, some people have it monthly, some people have it quarterly. And I would tell you, like with my experience, it is very aggressive. Like today you're working on a code, you're deploying a feature, tomorrow you get a request, you don't even get a request, you already know when you're working like feature A, that feature B has to be dropped like after a week. So it's like you're focusing on multiple different things, and things are changing with the advent of AI, and otherwise also things have been changing. You have to be competitive, you have to be up to the market. So every organization ensures that your product meets the requirements of what the industry is. So it becomes like really important for us to stay up to the market. And securing big data, now you have so much of data, like no hacks, no leakages, right? Again, coming from the cybersecurity industry, like I know like how it important, like day to day the scenarios that we see, right? Like we have banks and other things tied up, like how important it is to secure the data. And the data has to be consistent and utmost quality, because if you're just getting the data, but if it is not of the utmost quality, then your processing and the results driven from the data is likewise. So you need to ensure that the data is there, but how you're processing it, how you're utilizing it. Now, to solve all this problem, they introduce data analytics. Now, can anyone like just tell me, like with their knowledge, like what exactly is data analytics?
Visualizing the collected data.
Right. So that's why they introduce data analytics. It's frozen, just a second. Yeah. So they wanted to solve all these big data problems, right, with data. So they introduced something called data analytics, where they work basically on the data, extract like meaningful insights from them. Now, they apply all the analysis on top of the data. So little bit with data analytics, we are deviating from the original data problem, but I just wanted to introduce this, that why data analytics was used. It is basically to solve all the challenges with big data, and in general data, where you apply all your visualizations and analytics on top of your data. Now, there are different types of data analytics. Again, like I just wanted to introduce this because it was part of your course, and I thought like it's relevant in terms of like what the challenges are. So that's where I intended to introduce, and some of this you would have already gone over before I moved to like Hadoop and Apache. So there are different types of data analytics, if we can say, and these are like in three buckets that we have. One is like the business intelligence, second is like descriptive analysis, and then is predictive. Now when we talk about BI, right, now there is a really good example, as you would see in the screen. Like, how do I use data to learn about my customers? What has been happening in my business? So if I would want to know these two questions, answers for this, then I apply the intelligence. So basically, all the intelligence applied to know about your business, to know about your customers. So that is business intelligence bucket. And then you would have the descriptive analytics bucket, where you would also want to consider that who are my best customers, who are my worst customers. Now, best and worst does not mean that the customers are giving me more money, so they are the best. The customers are giving me less money, so they are the worst. It is not really that. It's like the number of products that they are using, the number of licenses that they are using, how do they turn the data into the rules, the security rules that a enterprise has. So these are like descriptive analytics that you can basically retrieve. And then you have the predictive analytics part, where how would these customers, based on my current experience, behave in the future? So you're somewhere like doing the predictions and the forecast, saying that okay, I have like 100 customers now, and particularly the scope of these 100 customers, because their business is also growing, right? And you would have like their trends also, like some trends would say like, okay, this customer in next 2 years will be generating 1 billion revenue or like 2 billion revenue. So if the customer grows, then he's also giving you business, so you grow. So that's another way to do that predictive analytics, saying that um, if the customer is growing, like how many customers I do have and what will be the growth rate. So these are like three different buckets that we have in terms of data analytics that you can do. So this part basically comes like when you're applying analytics on terms of the data, like data is already there, you're processing the data, but why it is important for me is basically in terms of analytics, it will give me all this answers that you can see in different aspects, and which is most important for any enterprise to know that okay, today I've done like in terms of the revenue that the organization is going to generate, so in terms of all those business market share products and things like that, so all that analytics is given by the data analytics part. Now getting back to big data, so we also looked at okay, how I can analyze the big data, what is big data, but where is this data hosted? So it is definitely hosted in servers, and if you consider cloud, it will be the compute instances in the cloud. Now where it will be stored, it is basically a storage place. So if it is cloud, then if you are in considering like AWS, it will be Amazon S3. If it is Azure, it will be a storage account. And if it is GCP, it will be the cloud storage buckets. So based on the cloud provider, you can store your data. We are not going to consider any on-prem or the physical servers, because here we are mostly talking about the digital data. Now, there should be like for any code that you write, you use your Python languages, like or Java or programming languages, right? So to process the data, so there is a programming language to the data itself, which is like the distributed processing that we talk. And mostly the programming language, it's not a language, so language would not be the right term to use here. But the way that it is processed is using MapReduce. I would be talking about MapReduce in next few minutes, but that is where it is being used. Now, the data that has been stored, it should also be stored and indexed, right? Like in databases, the format at which you store the data. So that's also important. Like you cannot simply store the data saying that the way you get it, right? You have to process the data, clean the data, and there'll be a way to transform the data and store it. So the way you store that data and index it, so there are different kinds of databases provided. So you would have been studied about like DBMS, and then relational, non-relational, and different types of databases like SQL, Postgres, and things like that. But when we are talking about like big data, the most used database is MongoDB. Now, and then what are the operations that are performed in the data? So you can perform like semantic analysis or any analytics that you would do like in terms of data. So this basically, this slide gives that holistic view that what you're doing with big data, like where it is stored, how it is processed, what is the programming model used, then is the data indexed, and if it is indexed, then how it is. So this just gives like a brief on the tools used on big data. Now, before I talk about like anything further, can anyone tell me the difference between parallelism and distributed computing? Have you heard these terms like distributed computing and parallelization?
Yes, ma'am.
So, just any difference, like what is parallelization?
Well, in parallelism, in that we have a single system wherein we just upgrade the system requirements, let's say the CPU or RAM. And in distributed system, what we do is we separate the computers, or there are multiple computers for our need. So whenever any request comes, based on the traffic, it's distributed. There, because of that, scalability increases in distributed system.
Correct. Yes. Yeah. So mostly we go with distributed systems rather than parallelization. As you mentioned, in parallelization, you basically have a single cluster or a single server, but the jobs are run in parallel. The tasks are run in parallel, but everything is served in a single server. But when it comes to distributed computing, so you have multiple systems like multiple CPUs which can run in parallel. So that's the major difference. Now, the drawback or the limitation of using parallelization is because you're heavily relying on a single cluster. So just imagine if something happens to the cluster, then all your jobs are at stale, like all the tasks are at stale, like nothing works. But in a distributed manner, even if a particular node goes down, you can still work on the other nodes. So that's the main advantage, and you're not really relying on, like, fault tolerance is there. Like, there are many more advantages to it. And that's exactly the reason, like, why we are going with distributed computing. It's basically, you'll have like different ways of processing your data, right? And distributed computing like ensures that your things are done seamlessly, because in a single server, like in terms of storage also, so it will have a limitation of how much you can store, and the compute capacity you cannot increase, you cannot scale, as you mentioned. And if everything goes down, then you don't even have a disaster recovery plan there. And processing also gets slow if your bandwidth and latency is slow, because everything is reliable on a single compute. But in terms of distributed, you can basically distribute, as the name also suggests, like when you have multiple nodes, so you can distribute your workload, saying that, okay, this node is capable of handling this much amount of data at this much bandwidth and this much latency. And likewise, you can handle all your different nodes. So scaling becomes like easy, but when it's a single node, you cannot really scale. You're all dependent on the single server or the single cluster that you have. Now, when we're talking about big data, we spoke about like the analytics part that is being done on the big data, and then we also spoke about like how it is stored and things like that. So people came up with few technologies on big data, which also, like, just imagine when you have to do it all of these yourself and you don't have any platform to do, then it is going to be like really difficult, right? If you have to spin up your own servers, maintain your own servers, cost and things like that, and everything is difficult. So that's the reason they came up with these technologies which simplify your whole experience of big data. And the top, so there are a lot of technologies, but we'll talk about like the top three or four that we have. And the most famous and the most used big data technology is Apache Hadoop, as you can see. Now, Hadoop is basically Java-based open source framework that we have. And they have a distributed file system, which is the storage, which is the main core component of Hadoop. And they have a concept of master nodes and the worker nodes, which I'll walk over in next few slides, the exact architecture of Hadoop. But this also ensures that your data is replicated in the cluster, and it is highly scalable, available, and they use this programming language called MapReduce in terms of processing your data. Like, that's the logic, if you can say, the way that they apply. But the core of Hadoop is HDFS, which is Hadoop Distributed File System. So I am just introduce the technologies before I go into the deep dive into Hadoop and Spark. So this is one of the technologies that we have. And then there is another called NoSQL. So with the name, you can say like it's not only SQL. So it mainly is advantages to handle. So Hadoop can handle both like structured, unstructured, but NoSQL is mainly used to handle the unstructured data with no particular schema, and it gives better performance with respect to unstructured data. And then I was talking about like MongoDB, right? So you can see like these are the databases that have been used like with NoSQL. So you can do your Neo4j integration as well. Neo4j is basically a graph DB. The use case of Neo4j, like just for an example, if I would highlight, is um, in multi-cloud architectures, mostly people go with databases like MongoDB or Neo4j DB, where you want to handle multiple tenants working in multiple regions. Regions, by what I mean is geographical locations. Like, you would have your customers or clients in multiple locations, right? Not just like um, India or US or Australia. So when you have multi-tenant architectures where tenants reside in different geographical locations, and their data and their information is resided in these big handling databases like Neo4j and MongoDB. And then another most famous one, like more than Hadoop, like Spark is used now, which is Apache Spark, which is but it is built on top of Hadoop. and it is much more prominent than Hadoop. We'll go over the difference between Hadoop and Spark in later slides, but Spark is basically the engine for processing big data within Hadoop. So it is not going out of the boundary of Hadoop. So you can imagine like it's giving you special features on top of what Hadoop already gives you. And it is built inside the ecosystem of Hadoop. So you can say that you're using both Hadoop and Spark. Now, before we move on to Hadoop and Spark, which is the major focus of the session today, any questions, anything that you would want to bring it up before I walk through in detail? Okay, if there's silence, then I would take that as a no question.
Students, if you have anything, okay, because we'll have hands-on after that. So you need, if you have any queries up till now, you are free to throw questions.
Yeah.
Okay, sir.
Hello.
Yeah.
Yes.
Yeah, ma'am. Actually, before diving into the hands-on, can you just walk through how the big data is collected in enterprises? Like, is there any pipeline or any specific software used for that?
Yeah. So hands-on will be the later. So the software, when we talk about these technologies, right? So it's nothing but like Hadoop and Spark where the big data has been collected. But when you're working on cloud, so it's a different concept in terms of cloud, which I'll again go over in the next sessions tomorrow. But there is definitely a pipeline. There is a ETL pipeline that we call, which collects the data, and there is something called BigQuery, which keeps collecting the data and runs query on top of that big data and give you like you can have data analytics as a separate what do you call, like third party tool on top of the data, but you can have like cloud native solutions also where the data is automatically coming into the cloud and then you're running your queries on top of that data. So this is like a short answer to your question, but definitely I will be talking about that in next few minutes, and also tomorrow that you'll understand that better when I cover the cloud.
Yeah, thank
I
you.
hope that did answer. Yeah. Okay. And and I just one more few more examples that I would want to give you. Like if you all know about Yahoo, right? Yahoo was like one of the first adopters of Hadoop to index the web at scale, basically. So Hadoop has been leveraged by like many companies. There is like n number of companies that I can list, but Yahoo being the most famous, like was one of the first to leverage Hadoop. And Hadoop was introduced basically to with whatever challenges and limitations that I walked through, right? Like too much data coming in at too much speed, and then we don't have like that much of compute and storage to basically process at the initial stages. So Hadoop was introduced to solve like all those big data challenges by introducing distributed storage and computation. And that distributed storage and computation is nothing but it's called like HDFS and MapReduce, which we'll go over in next few minutes. So HDFS is like the core of Hadoop. And if I have to say it in a very basic manner, HDFS, what it basically does is all the data that it's coming in, it basically put it into chunks, like separate chunks, and store it across the multiple servers that we have, because we are going with a distributed model, right? So you'll have like instead of a single server, you'll have multiple servers. So HDFS, what it does is it basically breaks down your data into different chunks and stores it in a different servers. Across multiple servers, it will store your data. Okay. Now, yeah, let's go over like what exactly is Hadoop. So it's basically a technology, open source technology that we have, and it's called Apache Hadoop because it's open source and it was introduced by Apache with Apache license. Now, HDFS, I already introduced saying like it's the core of Hadoop. We'll go over the architecture of HDFS in next two slides. So you will understand like where HDFS and MapReduce stands for. But these are like the most two critical components that you should know. And as I said, like all the data that is coming in, it breaks into chunks and it stores into multiple servers. Now, MapReduce, what it does is it's that programming model for processing that data. It maps like all the input received, and then you process that data, and then it sends you an output. You'll understand all this better with the examples that I will throw you in next few slides. And Hadoop works with both unstructured and structured data. Now, this is the ecosystem of Hadoop. So as you can see, there is a storage layer where HDFS is there and HBase is there. Now, then there is a data processing layer. So first the data comes in, you basically store the data. Then you have to process the data which is coming in, right? So you'll use your MapReduce, which is, and then there is Yarn. Then you have to have a way to access the data for querying that data. So you'll have the SQL, you'll have data flow if you want to do anything with AI, machine learning, and you'll have Avro, Scoop. And then you also have to keep managing the data in terms of like monitoring. Now your data is there, you're doing all the querying, but you also want to ensure that your data does not go down. It provides all the analytics that you need. So you have to constantly keep monitoring that data. So that's where the monitoring layer comes in. So in general, these are the four layers of the Hadoop ecosystem, if I can say. But as per your curriculum, we'll be focusing more on HDFS, Yarn, and MapReduce, because these are the three important things needed for you. So that's why I'll be like focusing on these three. Now, HDFS stores large data set across a cluster, and then it replicates into different servers that we have nodes. Yarn basically was introduced in Hadoop 2.0. So when Hadoop came in, right? So right now you would see like Hadoop is running like 3.0 version, but majorly in enterprises. But when it got introduced, when basically this Hadoop itself as a technology was launched, so in Hadoop 1.0, you would not see Yarn. You would just see like HDFS was there and MapReduce was there. Now, there were limitations with that 1.0 technology. So that's where they introduced Yarn in 2.0. And following from 2.0, Yarn has been a major advantage in many ways. Now, this is a basic high level architecture of Hadoop. As I was mentioning, that you have your HDFS layer as a storage, and then you have your MapReduce to do that programming on the data that you have. Now it follows this master slave model or master worker model. People call it like different ways. You can call it as a slave, you can call it as a worker, and then you have your master nodes. So your master is basically, you by the name like master, doing the things and then scheduling the server nodes. So in the master node, you have your, there are two important things here. One is called the data node, and the second is called the name node. And then you have your job tracker and task tracker. So master node, basically whatever your data comes in, if you it redirects it to the worker nodes. It gives tasks like different tasks to the different server nodes that you have. So this is like a very high level architecture of Hadoop. So you'll have your master and the slave, and then when the data comes in, it first comes into the master. Master assigns these jobs to different slave nodes or the worker nodes accordingly. Now, how does it assign? What's the logic of assigning? We'll understand that. This is at a high level, just a diagram on how a Hadoop cluster itself looks like. And then you can like scale it to, so all this that you see like 1 GB, different, these are like different nodes that we have in a Hadoop cluster, and you can scale these up to like 4K nodes. Just wanted to show like how it looks like in that. Now, when we talked about the architecture of Hadoop here, right? When we are talking about like the data node and the name node, and in general, when I mentioned that data comes in and then it goes to the master, and master ensures that it goes to the slave. So those are like the components. So how does it understand that it has to go to the master and then it has to go to the slave? Is basically that there are two important components. One is the name node and the data node. Now, the name node is that primary node which contains the metadata. Now, what is metadata? Is basically the data of data. Now, if you recall, when I was showing the semi-structured data, right, which is the JSON format, mostly it is the JSON format, where whatever information that you have, there is a metadata of that information created. Now, why is metadata necessary is because you don't really store the original data, you store the metadata, which is much more easily accessible and faster. Now, so name node being the primary, so it basically require fewer resources than the data nodes and store that actual data. So name node stores the metadata, but the data node stores the actual data. And the HDFS basically ensures that there is coordination between these nodes, and it acts like the heart of the system, as I was mentioning. Now, as I was mentioning, I'll introduce all of these, like what is HDFS, what is MapReduce and Yarn. And then when we go with hands-on and things like that, you will understand like some of these more. But I wanted to like not just like deliver theory too much. So I just wanted to introduce like what these three are. So that's why I'm like talking about them. Now, MapReduce, as I mentioned multiple times, like it's that programming language or model for doing the processing on the data. So each node processes that data stored on that node. Now, with the name, you can see like there are two things, right? One is called the map and one is called the reduce. Now, what is map? Map means like strings from a CSV file. Now, all of you would understand CSV file, right? Which is a data set or a data frame stored in CSVs. Now, all the strings that you would take from that particular CSV, or all the data that you would take, like the single data from the CSV, those are like map. Now, when you map that particular string to another string, so that's where you're reducing the data and mapping the key value pairs. So that is like the reduce operation that you're doing. Now you're basically concatenating them into a string, or you're mapping the key value pairs. Now let's take an example. Now I have like three sentences here, like John has a red car which has no radio, Mary has a red bicycle, and Bill has no car or no bicycle. Now these are three sentences, right? So when the processing logic happens, so so there are like three servers, let's assume, in the cluster that we have. It is scalable definitely, but let's assume for now that we have three servers. Now each of the servers picks up one of the sentences. As you can see, like it is being distributed, right? So each server has picked up one of the sentences, and there is a in that map, with each of the word you can see like how many occurrences are there. Like John is only occurred once, has word has been occurred twice, so the count is 2. And similarly for all the words, there are counts written. Now, so that is basically your mapping. Like based on the sentences, each string has been picked up from the uh, source that we have, be it a CSV or be it a data set from wherever it is. It has been picked up, and then there has been a mapping done, that how many occurrences of each words have been done. Now, in reduction, what happens is it basically goes over all of these servers and it consolidates in these three servers that overall how many occurrences have been occurred. So if you can see, like all the has words from different servers has been picked up together. All the red words, like all the duplicates that we have, right? They have all been picked up together by server 1, and then few words have been picked up by server 2 and server 3. And then all of these together later as a final output that you would see, overall it's consolidated and said that okay, John is only appeared once in all the three sentences, has been appeared four times, red has been appeared twice, a has been appeared twice in server 1. In server 2, for the second sentence, you can say that car has been twice, Mary has been one, and similarly for the third sentence. So you can see like all the once the data comes in, the logic that has been applied in terms of first mapping the data, like pulling out the strings, how many occurrences, and then reducing the strings across different servers to give that consolidated view of this particular string has been occurred this. So the processing is happening with this map and reduction technique. So this is like a proper example to explain you like how that is being done. Now, overall, as I was mentioning, like in Hadoop, like HDFS and map and reduce are like the two important things, right? So whenever you have a large data set, big data that we are talking about here, so say when a client access that big data, what really happens is the client like apply some processing or just want to apply some function on that big data, where it wants some analytics on that big data. That's the second step that you can see. So what really happens in the backend is there is a job tracker, so which is from the master node. It basically collects the data and then it assigns the data to different server nodes, which is the task tracker's job to assign it to different server nodes. And then the map reduction technique is applied in each of the servers, and then you get the final output out of it. So this is like the entire flow of how the data comes in, how the data is processed internally, the map reduction technique, and then you get the output. And the storage of that data happens in HDFS, which is the distributed file system. Any queries here before I move on?
No.
And I hope it's all clear, right, up till now?
Yeah.
Yes, ma'am.
Okay. Probably then I think we can take a 5 minutes break, because I don't want your focus to go away with too much of theory coming in. So, and then we'll resume after 5 minutes, like dot at 6, if that's okay.
Ma'am, I think
Mm-hmm.
you can continue.
I can continue?
Because, yeah, because now everything is in full flow.
Okay, sure.
So it is interesting. So you can continue, ma'am.
Okay. Yeah, just wanted to ensure so that I just don't want that I keep I know like this today's session, because the concepts, see again it depends on the concepts that you're covering, right? So I have ensured the hands-on is there at the end, but tomorrow's session will be like much more in terms of hands-on, because we are dealing with cloud. But some of these concepts in terms of the theory, it's much more important to understand, and I hope like I'm being more interactive and not just like it's not going out of your mind was my only goal, yeah. So
No, we can do one thing, ma'am. Once you switch to hands-on, I think that time we can have 1 or 2 minute break. That's so.
okay,
Till
sure,
then, the theory part you can do at one flow, ma'am.
sure, sir. Okay, thank you.
Yeah. Yeah.
All right. So, so the again coming back to the first this particular thing that I was mentioning, right? So data is coming in, how it goes. So I just want to show like in terms of architecture, here we are focusing more on that job tracker and the task tracker, because at high level I've just mentioned. So again, like recalling from where we came, right? So we have Hadoop. This is the high level architecture where you say like you have the master node, you have the slave node. A client basically has the big data stored, and then it provides some function or analytics to say that, okay, I need this analytics on my data. Now that basically is being picked up by the job tracker and the task tracker, as we can see here. Coming back here, so first the job tracker picks it up and then it gives to the task tracker. So the managing of the cluster resources happens at the job tracker, and then it schedules to the different task tracker, that it says that, okay, I have got this much data. Now it's your job to distribute that data into different server nodes, assign the tasks, and then each task will be picked up by the different nodes. So Hadoop one architecture was this. Now, the limitations were again that max cluster size, that you cannot go more than like 5,000 nodes. So if you recall again the traditional system that we had, right, where you have a single server and you have like everything going on, and then distributed computing came in where you have multiple nodes. Now with distributed computing also there are limitations now. Now the reason being that you have too much data, you have too much nodes, but that is still not enough. You still need more, and the number of tasks that are running in parallel is also not enough. Like I cannot run like more than 4,000 tasks. Then synchronization that happens between the data, because some data goes to server 1, some data goes to server 2. How do I know that server 2 is in sync? What if server 2 goes down but server 1 is still there, but I need some data from server 2? So all of these issues, right, that like scenarios that I'm giving you. Now how do you ensure that all these parallel systems that you have are all always up and running? There is a backup to it, that okay, if something goes down, then I have a DR for it. So multiple scenarios. So Hadoop 1 was also not enough. So then what they did is they came up something with 2.0, a different version, where in Hadoop 1 batch processing used to happen. Like, so basically whatever we spoke about, that's called batch processing, where things are happening in parallel. So that happened in Hadoop 1.0, as you can see with HDFS and MapReduce. But in 2.0, it basically covered up the limitations of 1.0, as we spoke in the previous slide, like all of these limitations that has been listed here, and it introduced something called yarn. Now, yarn was the major thing that got introduced in Hadoop 2.0 and forward all the other versions of Hadoop that has come in. So yarn was the major thing which basically solved all that problem. So it is not really helping just with batch processing, but it's also helping with streaming of video and audio apps. Like, streaming is the major quality that has been introduced with yarn, and it's much more interactive. Like, we got like CLI approach as well. CLI is nothing but command line interface. So with Hadoop 1.0, you cannot really interact with Hadoop with CLI, but with 2.0, you can really interact with Hadoop with CLI and other options that we have. So Hadoop 2.0 like played a major advantage in terms of the architecture itself. So that's where yarn got introduced. Now, what is yarn? So yarn is something where by the name, it is basically yet another resource navigator. So you can like, so let's take an example. Now, Uber we all use, right? Like Uber, Ola, Rapido, and the apps. Now, say if Uber has to allocate cars for multiple riders based on availability and demand, because if 10 people in a particular area wants to go to different destinations, and there are like 10 riders available. Now, what is the logic applied to allocate 10 riders to these 10 or 15 people that needs the cabs or the two-wheelers or whatever, right? So what is that logic? Now, yarn is that resource allocator, which basically gives that logic. So it interacts with that data in multiple ways, and then it ensures that all the data is in one place. So when we were talking about one of the limitations of 1.0 architecture, right, where I also mentioned one of the scenario that you have some data in server 1, some data in server 2. Server 1 needs to access some data in server 2, but server 2 has gone down. So if the data resides in multiple places, then I'm like, I've just lost that data of server 2 because it is not up and running. But yarn stores all the data irrespective of the nodes going up or down, or whether even if it's an active state, then the processing time or the other factors that comes in. So yarn ensures that all your data resides in one place and the processing happens from there. So it ensures that the resource management that is happening inside between the master and the worker nodes is done in a better way compared to the 1.0 architecture. Now, again, as I mentioned, like yarn is yet another resource negotiator by the name, the abbreviation yarn, and it helps like manage resources across the cluster. It stores all the data at one place. And while we spoke about HDFS, and I want to like little bit of go back, because so that you'll be able to relate and have the concepts in your mind. So when we spoke about Hadoop, right, we spoke about the job tracker, task tracker, and there was this name node and there was the data node, right? So similar to, so these were the components of HDFS. Now again, coming back to yarn, so there are some components of yarn as well. It is called the resource manager, nodes manager, and the application manager. So you'll probably have to like keep these things in your mind. So resource manager is basically allocating resources for applications and system. Node manager works on that allocated resources like CPU, memory, bandwidth, and the application manager is basically the interface between the resource manager and the node manager. So resource again like allocates resources. Nodes work on those allocated resources like CPU, memory, and application works like an interface between the resource and the node manager. So I hope that was clear. Now, we spoke like yarn was introduced because of the limitations of Hadoop 1.0, and then yarn came in and it does the cluster management. But what really are those advantages we are talking about? Now, three things. One is the flexibility, the efficiency, and the storage. Now, the first thing is when we say like flexibility, So it enables like other purpose built data processing models like MapReduce, such as, so it is not just like batch processing, right? If when we went over, it's more like interactive, it's more of like streaming. So that flexibility is there. Like I just cannot like do batch processing where I just am ensuring that, okay, I have a server, it's given to multiple nodes which are running in parallel. It's much more than that. Efficiency, the processing speed, which was there in Hadoop 1.0, became much better in with the introduction of yarn, because now that data is stored in one place and the way the cluster management happens, so I'm ensuring that my data is processed in more efficiently, more effectively. So the performance is the reflection of this efficiency, that if it was processed in say like 2 minutes previously, now it is processed in a single minute. So definitely in terms of with the introduction of yarn, they saw like a drastic difference in terms of the efficiency as well. And then because the storage happened at a single place, so it became like a shared resource where things were stable, reliable. It didn't really depend on the different nodes that were there. So it could access multiple workloads, have the multiple workloads running, synchronization happened. So these were like the different advantages that came in with the introduction of yarn. Now so with Hadoop, we just want to give a little bit like summary of what we covered. So with Hadoop, we understood like what is Hadoop. Then we understood like two major components of Hadoop, which is HDFS and MapReduce. And then we saw that there were limitations in 1.0, and then with 2.0, they introduced something called yarn. So yarn came in with 2.0. And then, so this is all like one of the big data technology that we spoke about overall, talking about Hadoop. Now, the other big data technology is something called Apache Spark. So Apache Spark is another open source cluster computing framework, like as we saw. But what is the difference between Hadoop and Spark? So Spark is another technology, right? But Spark is built on top of Hadoop, and it provided more advantages when compared to Hadoop. So you can think about that what Hadoop also didn't offer, Spark offers. Like there are some more advantages that came in with Spark. So a few more like things to mention is, one is the processing speed, the fault tolerance, and then real-time streaming, like mostly the social media apps that we go over, right? Like Netflix, or maybe the cricket matches that happen, like things has to be streamed on Hotstar or things like that, real-time, lively, right? Because there is a huge audience which is like seeing those streams. So real-time streaming, and then in-memory computation, where you have the computation happens like in parallel, but you also have to store that computation in memory, because same the basic computer concept, right? Where you store things in the memory so that it is accessible. So in memory computation is one of the major advantage that we have with Apache Spark. Now um, can you say that like Spark was built because the map reduce that happened in Hadoop was slow? If you think so, is like, do you all think that Spark was introduced because the map reduce that happened in Hadoop was slow?
Yes.
Yeah, that's one of the reasons. Just give me 1 minute. Okay, sorry, I was talking on mute. I hope I'm audible, right?
Yes,
Yes,
ma'am.
ma'am.
You can continue. We can continue.
Yeah, sure. Thank you. Yeah, so I was saying like one of the reason that Spark was also built was because, so as you can see any technology that comes in, right? There is definitely something that has to be different between the previous technology, something that the new technology provides. And this is like a general concept, not like some like anything that you talk, like any new company that comes in, any new product that they serve, their ideal goal is to give something better, because otherwise why will people even consume them? So even if they are like, even if you compare like basic Uber, Ola, and Rapido being in the same domain, but like, or Amazon and Flipkart and any other e-commerce, so there'll be some difference between them, right? Though their primary goal is to do like online shopping and serve and things like that, but there'll be some things. But when we talk about these technologies, they were built basically to combat the limitations that were there in the previous technology. So one of the reason that Spark was also built was basically the map reduction that happens in Hadoop, that also happens in Spark, but it was slow. Like it was observed that it was slow for iterative tasks, especially when machine learning got introduced, and things that you do with machine learning, you have to be up to speed and you have to do it in that effective manner. So like Alibaba also uses Spark, and there are many more examples that I can give, like um, okay, one more thing that I want to ask, like which would be like interactive. So if Google Maps is basically want to, so you we all use like Google Maps, right? To see the locations that we don't know, or to basically, now just imagine that you want to calculate the shortest path. Google Map, the advantage, so it will give you like different paths for you to go to that particular destination, right? Now, if you want to know the shortest path in the real time, now in the back end, what does it use? Like, what logic can you think that it would have used?
The Digestas algorithm.
Sorry?
The Digestas algorithm.
Yeah. But that's like an algorithm, right? But when I'm talking about like any technology or anything that we spoke about, like what comes to your mind? There are definitely like multiple ways to do it, but with Google Maps being accessible by every user in the country, like if you would say, like not just country, like in the world mostly, so then it would use, and that's again a big data example, right? Where it has to store like multiple data, like multiple locations, multiple information, and again different formats. And it's not just the data storage; it has to also ensure that this particular road is closed, not, and multiple other factors. So can we think that MapReduce would work here? Or are they using like MapReduce in the backend to do that logic?
Ma'am, Google Map also rely on GPS data now.
Yeah, it is. But still it has to store some data, right?
Yes, ma'am.
So it also uses the MapReduce function, but it does not use Hadoop, it uses Spark. And we'll understand like better in next few minutes. So again, like basically to overcome the real-time processing and the streaming, Spark was introduced, where it was much faster. The processing happens like really fast. It is fault tolerant. In terms of streaming, like for all the social media apps that we have, Netflix, YouTube, and all the others. So real-time streaming, and then in memory computation is the most advantageous, because when something is stored in memory, it is more effective, it is more faster. Oh, yeah. So like we saw the architecture of Hadoop now, and the components of Hadoop, right? Like when we spoke about HDFS and MapReduce, we saw it like its own components that it had for HDFS and MapReduce. So similarly, Spark has its own components. Now it has like Spark Core, Spark SQL, streaming, Matplotlib, and GraphX. Now, each of these are used in different purposes, and as per the names, also you can understand that if you want to do anything with the querying, you would use SQL. If you want to do anything with the streaming, you would use the streaming, and anything with graph and machine learning and all of that coming in, you will use the Matplotlib and the GraphX. But the core basic of Spark is the Spark core. And I think as part of the curriculum also, you mainly want Spark core, so we will focus on Spark core for now. So when we talk about Spark core, there are two things that is most fundamental in terms of Spark core. Now it's called abstractions, but you can just consider as like two concepts or two things that you would want to know. One is the RDD, now resilient distributed data set. It is immutable. It is fault tolerant collection of data split across nodes. Now, one of the limitation that we are talking about, and I've kept on mentioning multiple times, right? Fault tolerance. Now, what is fault tolerance? Fault tolerance is basically where any data on the node goes down, then it should be able to still serve you. Like, because I don't care what happens, like I need my data, I need my analytics, right? So if something goes down in real time, I will not even know that something has gone down, first of all. That is like the application and the infrastructure team will do the monitoring and things like that. But as an end user consuming the application or the product, I will just care about 24-hour service to me, correct? So in terms of that, RDDs are basically immutable fault tolerant collections of data which has been split across different nodes of the cluster. Now, one example that we can take is like Spotify uses Spark RDDs for real-time music recommendations. Now, based on the app usage that you do, so you basically have your playlist, but based on a single app, a song that you have played, if you want to get the recommendations, then RDDs in the behind play that role to understand the music taste that you have and then give you recommendations. So an RDD in the backend is created based on the data set, and I'll also show you how to create an RDD in the hands-on that we'll have with a use case that we are going to pick. But these are the fundamentals of the data, which basically splits your data into different partitions, and then there are transformations which are run on the uh, partitions of the data that has been split in the different nodes of the cluster. Now, another concept, or you can say like component, is basically this DAG, which is the directed acyclic graph. Now, this is the scheduling layer of the Spark architecture, which eliminates the map reduce execution that happens in a single stage, but it will ensure that it happens in a different way. Now, with the example that we saw, like the previous example, that how considering those three sentences that we had, right? Like John had a red bicycle and things like that. Now, the way that map reduction happened is first the mapping happened and then the reduction happened, correct? Now, in between that, there is nothing. But here you would see like map and reduction happens in parallel, like in different stages, and these stages are interlinked with each other. Like you would see like multiple links connected to each other. So as part of your course, we'll not focus more on the DAG, though I've introduced the concept, but we'll focus more on the RDDs because I think that is more relevant as part of the course and otherwise as well. So yeah. Now, RDDs, in general, like as I mentioned, these are nothing but immutable, fault tolerant objects which have been split into different partitions on the node. Now, there is something called transformations and actions which happen on the RDDs. Transformations are nothing but like map, filter, join, union, and some of these again you will understand more on like as of now you would also just think about like some of the actions and some of the filters that you're doing, but you will understand more of these when you're actually writing the code and when you're doing the hands-on. And actions are basically if you want to collect a particular analytics, when you call the collect function or you call the reduce function, or you want to count that, say like I want to retrieve top 10 you no, top 10 customers of Amazon, top 10 customers of Flipkart. So you will apply a count function on that, right? So that count is basically an action. and it will return me a value. So when I say like count top 10 customers of Amazon, so it's going to give me a value. So that count is an action that I'm saying that do this and give me that actual value on that computation that we have. So, and these are part of the Spark core. Now, transformations can be like map, filter, actions like count, collect, which actually triggers the execution. And again, going back to the Uber example that I was mentioning, right? So, Uber filters the rides basically by transformations. So, in the backend, it runs the transformation. Then, when it comes to actually calculating the prices, and the prices can happen like at peak hours or at normal hours, right? So, based on the peak hour or based on the normal hour, so it will basically calculate, so that calculation so it has to give me a value, right? So that calculation, when it happens, it's an action that you're running. So I'm saying that now it is a normal hour, so calculate the value and give it to the customer that the ride will be like $500 or $200. But if it is a peak hour, then do that calculation and give me that value. So all of that calculation where you need an actual value, that is called the actions. But transformation is basically you apply that filter saying that this person has requested for a ride from this source to this destination, and the filters that I'm applying is how many riders are there in that particular area, and then basically map the closest rider to that particular customer who has been requested the ride. So this is like one of the real-time example that based on this use case we can understand that what are the transformations and what are the actions we apply. So I hope that was clear with this. Now, what is the difference between Hadoop and Spark before we go with any further? Now, definitely one thing we clearly know that there were limitations in Hadoop and real-time processing and things like that, and that's why Spark was introduced. Now, to exactly understand what are the differences, few things we already know. One is like only batch processing happens in Hadoop, but batch processing and streaming both happens in Spark. Hadoop has just the HDFS, MapReduce, and Yarn. But Spark has much more to it. It has the core, it has the SQL, Matplotlib, streaming, GraphX, where you can do much more with machine learning. It analyzes large volumes of data. This analyzes large volumes of data, but including the streaming data. So that's more important. Now, it is definitely considered cost effective for processing massive data sets, Hadoop. Spark is also, but it has more of like API model. Now, application programming interfaces. Now, you would already know about APIs, right? So when it comes to like, so it follows more of like API model, which is actually the enterprise standard of developing any application, and you can do all your machine learning analytics on that. And then in terms of fault tolerance, we already spoke like jobs, if one of the nodes go down and job has to get rescheduled. But in Spark, because the data is managed in one place, so even if the data is split into RDDs, if a node fails, it is still managed or recomputed. Like you don't have to worry about fault tolerance in Spark, as we already spoke. So this was all about like Hadoop and Spark. Mm, okay, another question that I have. Do you think that all the banks that we have, right, like the commercial national banks, do they use Hadoop and Spark, do you think? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yeah, banks also use Hadoop for fraud archives, but they also use Spark, which is so when I'm talking about Hadoop and Spark, as a concept, it is Hadoop and Spark because as we already know that Spark is built on Hadoop, so it is anyway using both. So for banks also, like Hadoop is important in terms of like the fraud archives, maintaining the database that this customer has done fraud or in these many transactions. But Spark is mainly for the real-time fraud detection, that whenever a customer comes in and if he is not legitimate, his transactions are not legitimate or any actions that he's performing, so Spark basically helps in that real time detection in that sense. And there was one stat that I was just like reading through when I was presenting this, was like during COVID-19, right? Spark has analyzed like millions of patient records for real time like dashboards and predictions. So while the pandemic was there and things like that, but when you look at the data perspective, right, a lot of data was being gathered in terms of seeing the patterns of how many people were like COVID positive, how many were negative. And in terms of technology, like Spark was one of the most used in terms of analyzing all of this data. Then Amazon also uses like Spark, Matplotlib to recommend you products instantly when users browse. So basically, when you want to search something, right, like a particular product on Amazon, now it gives you relevant information that this particular, so similar products, you would see that similar products category, right? And the same product by different retailers. So all that recommendations in the backend are handled by the technology Spark. And there could be, it's not just Spark, it could be more than that, but these are like some of the examples. And another like industry, if I would name like JP Morgan, so that also like uses like both a combination of Hadoop and Spark for risk modeling. So risk modeling is one of their primary businesses also. So they also use for risk modeling, risk assessment in the back end. So they both use like Hadoop and Spark. So these are like some of the applications or the examples that I just wanted to highlight when we also spoke about big data, right? So these are some of the technologies that uh, these customers use. So yeah, I think that's all I had in terms of theory. I think we can go over with hands-on, where you will understand and apply all of these concepts. We are going to do a hands-on on Spark, picking two real like use cases, because Hadoop, we cannot really like do the Hadoop implementation. So we'll pick up Spark because Spark is like you can do it on Google Colabs, or you can do it on like Databricks or Jupyter Notebooks. So we'll do it on Google Colab. So probably what I'll do is I'll walk you through like few real world similar type use cases, and we'll do a quick hands-on, and then I'll also share you some problem statements that you can later like try it on yourselves. And then while we are doing the hands-on, I'll explain you also like how the RDD has been created, the transformation and actions that we spoke about, right? So that also will be able to apply in the hands-on, so you'll understand like how it is created, why it is needed. And then you'll also be able to see the visualizations, like when we pick up a problem, we'll say that okay, give me the like the questions basically that we want the output out of it, right? So we'll also be able to see the visualizations. So yeah.
Ma'am, meanwhile, I will take 1 or 2 minute break because we'll ask students to open their system and
Yeah, sure, sir. Yeah,
open their collab, Google Colab.
yeah.
So I want all of you to have one two-way interaction. Like you can also do the hands-on. Okay. So whenever ma'am teaches you, so you can also do practice from your side. Is it okay?
Yes, sir. Yeah, that's my
No,
goal as
no, no. I'm asking students from I think
well. Oh, yeah.
yeah. Students, is it okay?
Yes,
Yes,
sir.
sir.
It
Yes,
comes from
yes.
yeah. Yeah, so I'll give you 2 minutes time. Okay, if you are having your system with you, so you can just open Google Colab because ma'am will show you now in Google Colab, or if you are having Jupyter Notebook or anything, so that also.
Yeah, Google Colab I chose because it's much more easy. You just need a Google
Mm,
account. You don't have to do any
mm,
installation. So you can just click on the
Yeah,
link, and if your account is already there, then it will open up.
yeah, I think that will make good for them. So all of you can use Google Colab as ma'am suggests, and yeah. Ma'am, we'll take 2 minutes break because of this and I think now it is 6:29, so I think 6:31 students will be back with their setup.
Sure, sir. Yeah, no problem. You can take like
Yeah, yeah. Thank you. Meanwhile, if any other students have any questions, I think you can ask, okay, in between, if you want, if you have any question, because we don't want any this to be a gap or something. Any students who wants to ask any question, any doubts till now?
No, sir.
Okay. Students can refer to the chat box. Ma'am has shared two links. Okay, I think you can refer that. Uh, Students, shall we continue? If we shall we start?
Yes, sir.
Yeah. Ma'am, I think
Sure, sir. Yeah.
we shall start. Yeah, yeah, sure.
Yeah, I'll share my screen back. I hope all of you have opened up the collab, right? Yeah. And I've also given you a drive link. So that drive link basically contains this Google Store, the data set. So you can probably like download that data set on your systems, because when we are going to do the hands-on, that will be the input for us. And you can also see like what is in there, the data set. Now, one of the use case that I've picked up is the Google Play Store. So Google Play Store data. Now it has like all the different apps, the categories, like you can have like gaming apps, which goes in the gaming category. Then you also have the banking apps, which is like, which goes in the banking category. Then you have your e-commerce, right? So multiple categories we have and multiple apps. Now we also have a rating that the customer gives, as we as users also give ratings. We give the reviews. We also see like how many people have downloaded the app, the installs. Some people download, reinstall. All that install information is there. The type and the price. Now all that information is there in the data set. Now you all understand data set, right? Data set is nothing but a large collection of data. Now before even going to the problem statement, now, there are three things. We already got to know about RDDs. Then we also know about data set, and you would have also learned about data frames. But what is the difference between the three? Like they all look similar, correct? Like RDDs, data set, and data frames. Then what is the difference? Can anyone like mention what's the difference, if anybody knows? Okay. So the fundamental, so RDDs is basically the fundamental data structure in Spark. We already, it is immutable and then it is distributed across nodes. Now, data frame is also a distributed collection of data, but it is organized data. Like it is organized into different columns that you would see. But when it comes to like data set, it is basically a combination of both RDD and the data frame together. Now, it is more of like object oriented, if you would consider in that sense. So this is like the primary difference between the RDD, data frame, and the data set, if you would understand in that sense. Now, like in terms of abstraction, like RDD is like low level, data frame is high level, and data set somewhere falls in between. Like it is not even like low level, nor it is like high level. And there are like few schema differences between the three, but fundamentally you can just for your knowledge, like understand that um, RDDs are like more object oriented. um, it is like um, the fundamental data structure in Spark, and it is immutable. Data frame is like the distributed collection, but it is more into like a structure, like it has those column like structure which you basically pass in a SQL table. Now, say if you want to store some data in the database, now you will have the columns, right? Like the name column, the ID column, the age column. Like if you take like some example of a customer data, then you will have the name of the employee, then you will have the age of the employee, the type of employee he is, like which department he works in. So all of that is like a structured data, right, that you're storing in tables. So for that you'll have the data frames, and data set is basically a combination of both RDDs and the data frames. And the reason I wanted to introduce dataset is because mostly in all the LLM models and everywhere that we are going to work on the use cases, we are all going to use a dataset. Like one of the datasets that we have here is the Google Play dataset that you would have seen, right? Like if I open up the Google Store, are you seeing my whole screen or are you seeing just the document? I
We
hope
can
you're
see the
seeing
whole
the whole
screen.
screen, right?
Yeah, we can see the whole screen.
All right. Yeah, so I just want to open this Google Store dataset that I shared. Yeah, so you would see like a data set is like this, like you have like multiple types of data like app, category, rating, reviews, and everything that we spoke about, right? So now what do we want with this data? Now the task is basically you have to get top 10 apps by reviews, top 10 apps by installs, distribution of free versus paid apps, category wise distribution of the installs, top paid apps by installs, top paid apps by rating. And additionally, you have to visualize all this by bar charts or whatever, export in a particular PDF. You can also like store it to the drive. So, but basically, these are the things that I need. Like as a Google Store overviewer, if I have to see, then I want to understand that which is the most topmost app that people have been using in terms of reviews and things like that. Now, if I have to get, so this is again like data analytics, right? I have the data. Now I want to basically get all this information for my things. So then what we'll do is we'll first do the installation of PySpark on our hands-on lab, the Google Colab that we have. So for installation, so probably you can do the commands with me, or I can share the commands and you can try it out yourself. We'll go step by step. And then if you have any issues at a step, we'll pause for a minute, we'll solve that, and then we'll go to the next step. There are just like 5 steps to it. It is pretty straightforward. So let's do this. So let's first install. So probably you can do this installation with this command. I'll keep pasting in the Zoom chat so you can like try it out yourself. Now where you're going to try it is the Google Colab like opens like this, right? You can create a notebook if you want, or you can use the existing notebook that you have. Have you all like used Google Colabs before, or is it like the first time? Just want to know.
We have used before.
You have used before, right? So you understand
Yeah.
all of these, like how do you write a code? Like if you want to write a code, you basically get this snippet when you add the code, and then if you have to run the code, then you run this command. If you want to run all the commands writing it once, then you just do run all. So these are like some of the basic things I just want to walk through. Like I know all of you know, but just in case.
Yeah, actually, most of the students know about it. I think all the students know they have lab. In that. Although they have done it in different environment, but still they are aware of Google Colab.
Okay, great, great. Sure,
Yeah.
sure, thanks. So then what we can do is I'll just paste the commands in the Zoom chat, and you can try out these, like probably, yeah. And then the second lab, then I'll just give the problem statement and all of you can try it out and then come derive with the output. So we'll do it that way. Like once one we'll actually do it together, and the second one I'll just give the problem statement and you yourself have to come up with it, and then we can see the output and I can help you wherever you're finding issues. So first we'll do the installation. So let me know once all of you have installed. And I'll explain like each line of code while we are going over this. Let me know once the installation is done. I'll move on to the next.
Done, ma'am.
Okay, okay. Yeah. The next thing is basically you need to, so you have installed PySpark because we are going to work with Sparky, right? And the Python one, so that's why it's called PySpark. Now, the first thing that we do with this is basically we open up a Spark session. So for opening up a Spark session, so as you can see this particular line of code like Spark equal to Spark session, and we give it a name because we are working on the Google Store data. I've just given it as like Play Store analysis, but you can come up with your own names, like not like you have to stick to this. So first things first is basically you create a Sparky session for yourself. So I'll just paste the commands and you can run this to create your own session with your own name. And let me know once you have created the session.
Students, please acknowledge once you're done, like give thumbs up or anything.
Done, ma'am.
Yeah, done.
Okay, great. Okay, so the next thing is now we have established a Sparky session. Now, because we are going to work with the Google Play data that we have, right? So we have to give the input. So for giving the input, we are going to upload the Excel file. Now, mostly when we are working with the data sets, we have to give the CSV file. So you in the drive, you would already have a direct CSV file, but if you don't have a CSV file, basically what we do is if even if you have an Excel file, you basically get the Excel file, then you convert that Excel file into a CSV file. So I'll give you like both the commands to do it. But if you already want to pass the CSV, it is up to you to pass the CSV. But if you want to upload the Excel and want it to convert to CSV, then you can do so. And another thing is when you do this command, like when you run this first snippet, which I shared, right, where the input is like this Google Store dot Excel file, you would see a button to upload the Excel file that you have downloaded from the drive. So you can basically um, choose that Excel file and pass the input. I could have shared all of this. I could have shared this document itself to you and given it to you to try. But I want to go over each of these is because you understand what you do. Because otherwise, what we tend to do is we just like copy paste, right? Okay, this is the first step. This is the second step. So here, like this will enforce you to like force yourself to understand this while I'm going with you, so that the next use cases or next hands-on or practice sessions that you have, you can anyways do it by yourselves. So my intent was to like go over this so that you understand it, because mostly like when you're given like a set of steps and you're given a document, you just like copy paste it and you just like skim through it.
Okay, if any students are having any issues till now, you can ask. Okay.
Yeah, anywhere you're stuck, if your command is not working, please let me know.
Ma'am, what exactly do in third command? Because it's not working, showing
Can
error.
you please share your screen? I can help you.
Yes, ma'am.
Yeah.
Just a minute. Ma'am, third command is as it is copy and paste in the third cell, na?
Yeah, you have to copy all these commands as it is.
Yes.
Third command is basically where you're, as I mentioned, right, you're passing the input to what you want to do, right? So the input is basically the Excel file that we are passing, which you would have downloaded from the drive link that I've shared before, which has that Excel file.
Ma'am, I have already download the both the files.
Okay.
Yes, you can share your screen if you want to
Yeah,
hear
you
you.
can share your screen.
Yes, ma'am.
Okay. Can you just cancel this and rerun it? I think probably you have not uploaded the file, so that's why it's giving that error. Invalid character. The codes that you have, right? It's taken as a special character. So can you like retype that?
मैम ये फिर से करना है मीन्स
Sorry, नहीं, the codes that is there, you have to rewrite those codes. It is taken as a special character. Let me annotate. 1 second, so you'll understand. This one, right? Just retype the codes. Because you're copying it from the Zoom chat, it is taken as a special character. Those quotes, right? Single quotes. Just do a backspace and retype it.
can I remove these columns मीन्स
The quote? No, you'll have to put the quote. Just put, yeah, type it again, yeah, at the front also. Yeah. Now run it. Now you have to choose which file. Take the control of it. Let me see.
yes ma'am
Just 1 second. Let me see if I can take the control.
yes ma'am you can control please
Just do a backspace before the hashtag. Run it.
Yeah, so now you choose
Now
the
choose
file.
the file. Yeah. Now
Yeah, where is your file? Probably you can take control back. Yeah, you can choose that Excel file, open. Yeah, and then so it's running it. Yeah, basically while copying from the Zoom chat, right? It got copied as a special character, that's why. Yeah, so this ran successfully. Yeah,
thank you ma'am
yeah, great.
now
Stop
you
the
shall
recording.
continue. Yes. Yeah.
Okay.
yes
Yeah. You can stop sharing. I think
yes sir
ma'am will continue. Yes.
Yeah, now the next thing that we are going to do is we are going to load with the schema. Now, basically based on the questions that we had, right? So let me first share the code in the screenshot, sorry, Zoom chat. Now, the next thing that we are going to do here is, so whatever input we have given, it has loaded the file. Now we are going to create a schema out of those. So with the schema, whatever we are interested in, because of our questions that we want to solve, right? We are interested in mostly like all of this data. So we are going to create a schema, a single schema for all of these data with the types. Like if it is a, like app is basically a string, rating is basically double type, long type. So based on the coding language, you can figure, right? Like some are strings. If it is a number, then it is a number. So basically, we are creating a schema out of those what we are interested in. But and it's also printing the schema. But when it's printing, we are only printing the first five. The reason being that the data that you can see, right? It's a huge data. So just for us to see the output, we will be printing only the first five. So you can now try to run this command. So basically, if we have to understand in basic sense, we have established a Sparky session where we want to get some output out of it. Inside the session, we have loaded our input file, which is nothing but the Excel sheet. Now we have converted that Excel sheet into a CSV because mostly we are working on the CSV format. Now with that CSV format, now we are doing processing of the data. We want to clean up the data because the data, the answers that we want to retrieve to the problem statement, it requires some processing of the data and cleanup. So that's why you will basically create a schema and you will do some cleansing of the data, and then you will ask it to give you the answers to the question. So that's why we are doing at this particular step, right? Load with explicit schema. You're basically creating a schema for all the input parameters that you need on your data. And in the output of this, you'll be able to see the first five.
Okay, any one of you can show your screen so that we'll get to know that whether it is really working. Because we want all of you to know the concepts clearly. That's why.
Yes,
That is
yes,
only intention. Yeah.
yes. And I can do it myself as well, but I want you guys to run it and show me. So probably any one of you can also share screen. That's also okay. But any of you are facing issues also can let us know.
Maybe yes, I think you can share your screen once again if you have completed, or anyone else. Mohammed Sufyan? Mohammed Sufyan?
Ma'am, showing error.
Yeah, you can share your screen. Yes, yes, yeah. Please share your screen. I think that would be helpful. Yes, yes.
सर तो रेडी हो गए तेरे लिए वेट कर रहे होंगे वो तो
Okay, I think this is again like while copying from the Zoom
Yeah.
chat. Okay, let me do one thing. Let me give you the document because I'm pasting it in the Zoom chat, right? So while exactly copying, it's giving the error. Let me see if I can share this.
Ma'am, you can share the part by
दोनों
part
रेडी की
document.
तरफ
That's
इतना
also fine.
Sorry?
A part by part document also. I think that also would be fine. Like,
It's there in the
is
entire
it,
document. I can share the document only. One second. I'll download the document and probably share it.
okay. I think students can work on it.
Hmm. Sir, is there any email or something? Because if I have to share a file or I can send it to you and probably you can share them and
Yeah, what I can do is that you share it to me,
okay.
and I have that Moodle, like Google Classroom, and I will post it there
Okay.
now immediately.
Yeah, yeah, sure, sir. I'll share it to you.
Yeah.
I have sent it to you, sir.
Okay. Let me check now. Okay. Okay. Yeah, I received. Let me share it with students. Okay, students, you can go to Google Classroom, and there you can find the file. You can download the file in data engineering classroom, data engineering theory classroom.
So it would have that Google Play Store, the first tab that you can see, right? So that will have all the commands. So you can directly paste it from there. You are able to access the doc?
Yeah, students, please, are you working on it?
Yes, the file is accessible.
Yes.
Yeah, no? Yeah. Okay.
Yeah, probably then, Yash, you can share your screen and then run those commands. It should be quick.
Okay, anyone can share the screen, please? Okay, that would be helpful for us. I think if voluntarily, if anyone can share their screen, we can also find out, okay, where you are going wrong. Okay, good.
Yeah. I think you see that error, right? In that DF raw line. There is a closing thing missing there. I think while copying, I think something got. That's a single line.
Yeah, that df underscore raw. Yes, you can go to that df underscore raw equal to spark dot read
Three dot option.
dot option, and for please make it one line. I think because of that copy pasting, it went to the other line. Yeah, that. Uh, yeah, go to that. Go to this part. Let me annotate.
No.
Or probably I can
Yeah,
take
no.
control and show you.
Yeah. You can annotate in this moment.
Okay, I'll annotate. See this part, right? This is something I think junk that has come in.
This one.
It is
Yeah.
not
That's
exactly copied.
Yes.
Yeah. So you have to remove that. It's just like header and that quote didn't come in when copying it.
Yeah, yeah. See that. Okay. Yeah.
Oh, sorry, I lost your screen.
Yes. Please go to that code. That is you go to Google Classroom where the code is. Go to the data engineering theory. Where the document. Yeah, yeah. See, now this has to be one line. Okay. This thing should be one line.
It will work in 2 lines also, but I think it should be written correctly. That had that code
Yes,
cycle.
yes, yes, yes. That's the reason why. To be on safer side.
Yeah, yeah, yeah. No, I think it again didn't get copied correctly. Are others facing the same issue with copy paste or
Okay, Om Rajali,
No,
are you
ma'am.
there? Anybody else who can show the screen? Or anyone there? If anyone
I
is,
can share. I can share,
yeah,
ma'am.
yeah, yeah, you can share Nakshatra.
Yash will need to stop the screen share for that.
Yes, please stop sharing the screen. Okay. Meanwhile, Nakshatra will share his.
yeah. Okay, so it ran fine, right? And you're
Yeah,
able to retrieve the first 5 rows. Yeah, great. Then you
yeah.
can run the next command. So this is where we basically got it to the schema and printed the first 5 rows. Now this is basically you're cleansing your data and normalizing it into the DF data frame that we spoke about, right? So you can try this out. I think all the codes are coming as
Yeah.
ampersand code. That's why.
Excuse me, sir.
Yes.
Sir, actually, I have downloaded the PDF Play Store report.
No. See, one more doc file is there. Don't go to that PDF file.
No,
You
sir.
should
I
go
have
to.
completed the code and the code executed successfully, so I have got the results.
Okay. You can show your screen then.
Okay.
Ma'am, there is one point we'll show the screen.
Yeah.
Let us see.
Yeah, sure, sure, sir. Yeah.
Hmm. Pranav, you can show. Yeah, what and all you have done. Yeah.
Yes, sir. Is it visible?
Yeah,
Yes. Yeah, you can. Yeah.
So actually, sir, I got this PDF after
yeah.
running the code.
Great.
Hmm.
Yeah, so you see, right, the top 10 apps by reviews. So this is listing that this is basically the answer to the question that we wanted, right? The top 10 apps, like how many install type and things like that. And then if you scroll down, You'll see like more visualizations of that. Like top 10 apps by installs, by reviews. So you can see like Facebook is the most one. Then you have the WhatsApp and Instagram based on the data that we have provided. Then the top 10 apps by installs. Then you would also see like further visualizations giving like free versus paid. What is the count? This is answers to the all the questions that we wanted, like how many are free, how many are paid, then how many installations that happened, top categories by install, like be it a gaming industry or communication or productivity. So all these visualizations you can basically see. Probably he has given a command to give it as a PDF, so that's why it all came in as a PDF, so that you can
Yeah.
share it as a report. So yeah, but you can also store it to the drive, and you can run like more commands to it. So this is how we do it. Like we basically establish a Sparky session, then we do pass the input. We do little bit of processing where you create a schema of your data set. Then you do the cleansing of the data set based on what you want, where that logic is applied. And then the next function that you're basically doing is you're calling those transformations. So if you would have noticed in the code in the step 5, there would be some filters and group by functions that you're calling, right? So wherever that filter, group by, so all of those are those transformations that you're running, like actions that we spoke about, right? And those actions and transformations, so internally it's creating an RDD. In the next use case, you'll explicitly be able to see that, but it's creating those RDDs, and then it's applying those transformations and actions on top of it to derive a value and then visualize that in this PDF, as you can see. So this was one of the use case. And then in the same doc, you would see another use case that I have picked up, where the use case is like this. We have an MNC, large MNC, a company example, and you give customer feedbacks, right? The lot of feedbacks coming in, and what you need to do is you want to understand like the sentiment of those feedbacks. Basically, is it a positive feedback or a negative feedback? You just want to derive at that. Now a lot of customers have given the reviews, and you just want to derive that whether the overall feedback is a positive feedback, negative feedback, or a neutral. So that's the second use case that you can try it out yourself. But this is more like it is the same way where you will basically load the data, you will pass your input file, you will run the sentiment analysis, and you will basically apply all the transformations that you would see in that particular document. So you can basically try that out when you have some time, or you can try it out now as well if you would want to. So these are like the two simple use cases that I've picked it up, which is similar to the real world examples that we have when we apply in our enterprises. Sentiment analysis, and then gathering of the data and processing of this data. Google Play Store, if you it has to give. You can do the same for like Netflix, Amazon, YouTube. E-commerce being one of the major industry that is relatable to all of us, right? So you can do like a lot of examples on those. So yeah. Any questions, any issues while you are doing the hands-on? Please let me know.
Okay. If you have any queries, you can ask now. And meanwhile, I have shared the feedback link. So this feedback link is attendance. Okay. So for attendance purpose, I'm not going to call your names. Okay. So you can go to that link and click on that link, and that will be the attendance for your session. Okay. So both the section, please go through that link, attempt that, okay, and that will be a feedback. That will be a feedback as well as your attendance. Okay. We'll give you 5 minutes time for that. And meanwhile, if anybody else have any doubts, okay, they can ask. Okay. Ma'am, can we have 5 more minutes? I think if any students are having, if time permits to you.
Yeah, sure, sir. Works for me.
Yeah,
I'll be here. Yeah.
yeah. So students, okay, other students, you can give feedback first. once you're done with the feedback, okay, you can come back and you can ask any doubts, okay, and in the end, we'll have a recap of what will be done in the next session. So, ma'am, you can tell what will be the next session so that students will be ready with that in tomorrow session, like what and all requirement is required for them for that.
Yeah, so next session I mostly want to go over like cloud concepts. So do you have any Azure account accessible? So do they have Azure or AWS?
AWS they have, but I think if you want to show Azure, Microsoft Azure, I don't think they are having any Azure, but you can show the demo. So
Okay,
whatever you show, so there will be recording of that. I think students can go through that once again through the recorded videos,
sure, sure.
and
Yeah,
they can also look back and see what you show and demonstrate. And AWS they have limited access. I think students are having the student access, student license. So
okay.
so you can have more hands-on on that AWS and but Microsoft Azure, you can show the normal demos, ma'am.
Sure, 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 sir. Yeah, then probably for tomorrow, the agenda will be I'll introduce the cloud concepts. The cloud concepts are generic in terms of be it Azure, AWS, or the GCP. So there'll be like
Yes,
some concepts that I'll cover in terms of like compute storage, like going over your curriculum that you have, right? Like the unit 4 that it specifies.
yeah,
So I'll go over like the general cloud concepts, and then we'll do I'll also demonstrate on Azure how it looks like and compare it with AWS. But AWS
yeah,
then we'll do hands-on because you have your student thing. But
yeah.
Azure, I'll demonstrate myself.
And some scenario based also if you can teach them
Sure, sir.
like yeah, that would be useful.
Yeah, sure, sir. Yeah.
Students, are you done with the feedback? All of you?
Yes, sir.
Okay. Okay. If you're all of you, I hope you have done with the feedback. And I'll give you one more minute time to share your thoughts with the ma'am. Okay, then once that is done, I think we'll wind up over this.
Yeah, please let me know, was the session
Hello,
useful
excuse me.
or sorry, go ahead.
Actually, I had a general question.
Yeah.
I just wanted to know, like, to get an opportunity in any company, for particularly in this role, data engineering role,
Mm-hmm.
based on these technologies like Hadoop, Apache, and all, Spark. What sort of projects you are looking at whenever an internship, whenever a person is applying for internship? The level of the project that you're looking at.
See, to be honest, there's nothing like level of the project here. Every company will have their own requirements, right? Like projects that they'll have. Like it does not matter which level it is in, like easy, moderate. They don't care about which level it is. They'll basically have certain requirements that they need to achieve. Now that's where they go hunt in terms of like if it can be given it as an internship. So they would mostly see you as like having concepts, knowledge, and the skills required. Like for example, with whatever in data engineering that we want to see, right? Like big data, Hadoop, data analytics, Spark. So if you understand the basic concepts of these, if you have done few hands-on practices on the examples, right? Like that, for example, the two examples that I got in, right? So some of these, and these are like real world examples as well. And you don't have to like wait for thinking through examples. Like you can leverage AI. There's ChatGPT, Gemini. You just list the use case that you want, and it will give you all the steps needed to for you to like come up with that particular use case that you have, right? So stress more on the basic concepts and skills. So if you have that knowledge and understanding of how Hadoop, what Hadoop is, Spark is, big data is, data analytics is, those concepts, if you know, then for internship, I think that's where we evaluate on your basic knowledge. And projects would depend on the organization's requirement.
Okay, thank you.
Yeah.
Ma'am, we thank you for taking your time. I think it was a very good session. It was an excellent session, I would say, and I think even students have enjoyed the session here. Um, so thank you so much for joining at this even at your at this time at this moment also. And uh, so tomorrow we'll have a continuation, and I hope even the students will like the other concepts that is on AWS and Microsoft Azure. And ma'am, what time you would like to have, whether it is at 11 o'clock or the evening session? Which session is preferable for you?
So 11 to 1 would be better. 11 to 1.
11 to 1 would be better. No? Okay.
Yeah.
Okay, students, so there will be 11 to 1 session tomorrow. So join at 10:55 or 11 so that we can have more extended sessions. So if you join early, okay, then we can have till 1, 5, 1, 10 and whatever the exercises. And thank you so much once again. Okay,
Thank you. So,
and,
so just before I close, I've just pasted a link in the Zoom chat. Just one more thing I
okay.
wanted to highlight is, in terms of skill for you to be ready in term for your like data engineering or things like that, right? One more thing I want to stress more on like big data, data analytics, and Sparky, like Apache Spark. Because that is something, three things that we look at. Hadoop, definitely, like they'll ask you in terms of concept, but they'll not ask you but nobody actually would leverage it as a Hadoop, because Spark is already built on Hadoop, right? So stress more on Spark. And there is a very good documentation on Spark, like everything that we spoke about, like how you have your Geeks for Geeks and things like that. So there is this link called Spark by Examples. And especially if you go for PySpark, the tutorials are really good. Like even if you like skim through or like handy document last minute thing, like this gives you like really good knowledge of things to keep in your mind and recall and things like that. So that's a very good example. And again, thing that I would tell you is stress on like doing more of hands on, because Google Colab is like the best for it to implement, right? Like you can just think of use cases, give it to the AI, it'll give you the code, try it out yourself, try the filter functions and the transformation and actions. So the more hands-on that you do, the more your concepts will be strong. So that's one thing that I just wanted to share. Again, thank you so much, sir, for the opportunity. Hope the session was good and
Ma'am,
interactive.
one last question.
Yeah.
Any prerequisite or any homework like they should do before joining the next session? Because if they want to study something, like if you want to have like prerequisite knowledge for the students, they will go through that once at least, and they will be ready. So something you have any suggestion in your mind?
In general, you can go over like cloud computing. Just understand what is cloud computing, why was cloud introduced, so that you will understand the link between today's session and tomorrow's session. And since you already have your student account, right? So some of the things you might have queries like why this is there, why that, and things like that. So just prepare yourself for those questions. Is what I would say. Like just go over in general what is cloud computing as a prereq for tomorrow's session.
Students, I hope we are clear with this.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, yeah. Okay then. Ma'am, thank you very much. And I think, shall we wind up?
Yeah, yeah. Thank you so much, sir. Thank you.
Thank you. Okay, okay. Thank you so much,
Thank you,
students.
everyone.
So,
Thank you,
yeah,
sir.
tell me, ma'am. You have anything to tell? Okay. Thank you. Thank you so much for joining. Yeah.